Welcome, gang, to week 3 of CS153. We have today with us Amit Jain from Luma. Thank you for joining us, Amit.
Thanks for having me.
Okay. Amit is going to be talking to us today about unified intelligence systems. You're going to be hearing a lot more about this. I think it's a very relevant follow-up to the visual intelligence systems lecture we had last week from Andy Blattman at Black Forest Labs. Quick recap on the class. And today we're going to talk about Amit. And today we're going to do a field trip into what I think is also one of the most exciting factories working on how to get work done, especially visual and creative work done in the world, called Luma. But before that, why don't we start by talking about Amit a little bit. I had the privilege to get to know Amit a few years ago when he was still an engineer at Apple. And I was at Discord at the time, and I got an email from Amit saying, hey, I heard you have a bunch of 3D data. Can I have it?
I remember that.
And I said, no, you can't, because Discord had acquired the data. But I started asking Amit why he needed the data. If you guys remember, I covered this in our first lecture, but Ubiquity 6, the company I started about a decade ago, was a 3D computer vision mapping company. And we had millions of people around the world who were capturing the world in 3D using their smartphones. And all that data, we had terabytes of data that were 3D representations of the world that we'd reconstructed from 2D images. And Amit said, well, I want to build a 3D service that is generative. I want to allow people to create the same kinds of meshes and point clouds and 3D representations of spaces, but through generative models, because that's where the world is going. And I got interested because I kind of agreed with him, and he was ahead of the curve. And so I had a chance to invest as an angel investor at the time, and then a few years later, I had a chance to partner with Amit again at A16Z when I was a general partner, and thank you for letting me lead your Series
B.
Yeah. Amit was also one of the first customers of the A16Z compute program called Oxygen, and actually helped name Oxygen as well. I think the quote was, he said something like, if we don't have compute on day one, can't really breathe.
Yeah.
So tell us a little bit about what Luma is, and what were the dots that led from the insight at Apple that generative modeling was the future that led here?
My background, very briefly. So at Apple, I was working on first the LiDAR systems that actually now is on our iPhones. This was called the Jasper sensor, if any of you are familiar. And we were trying to build, actually build what comes after the camera. This sensor was built, now I can talk about it because the project is no more for the car, which was called Titan. And we started to work on Vision Pro after that because the car project got canceled and the Vision Pro had a bunch of LiDARs on it. And during that work, it started to become obvious that the computers of the future, we still don't know what they will look like. Maybe they will have AI or whatnot. The computers of the future will need very different interfaces, will need very different kind of media, and will need very different kind of ways of actually capturing and creating and building those things into the system. So in 2020, at Apple, we started exploring generative models. And think about it, it's 2020, so before language model scaling was known to be working, and before, actually it was before DALL-E, but NERF had already come out from Matthew Tanchik from Berkeley. So we started to explore those generative systems, and that led me to thinking that, okay, if language scaling is working, and here is a method where differentiable 3D is possible. What would happen if all of these things are combined together, right? That would basically mean you have the full footprint of every observation in the universe, and you will be able to differentiably learn about them. If you can differentiably learn about them, you can understand them, and then finally you can generate them. So that was the genesis of Luma. And at that time, because of the pedigree we had, 3D seemed like the most logical way of going forward. Because first of all, 3D has a lot more information than images do. Naively, we assumed at the time 3D has a lot more information than videos do as well, and that 4D would be very easy to capture and scale. But again, I say naively because as you will learn in a few seconds, that was a bad assumption. But that's kind of where we started, with the idea of building what we now called a world simulator. At that time, it was just like, all right, if we can learn this and generate this, we would have something that would allow us world understanding.
And you talked about you said this phrase, which is important. Learn the world in a differentiable manner.
Yeah.
What does that mean?
Right. So, I mean, I'm sure you guys are all familiar with how transformers work and how AI models work. Differentiable means you can put it in a training loop, and you can have a loss function that can be then iteratively optimized. So, differentiable allows you to do that. If the function is non-differentiable, then you really can't do gradient descent on it. And if you can't do gradient descent on it, then deep learning doesn't work. So the tools that we have for this era, for this generation, is basically compute and gradient descent. And yes, transformers are things that are very, very well susceptible to gradient descent, but the actual thing underneath it is gradient descent and compute. So how can we take a lot of data, a lot of compute and gradient descent, and produce something useful out of it? Differentiability is the core characteristic of that problem, those problems, basically.
Yep. That's helpful. Can you just connect the dots on what that insight led to then what Luma is doing today?
So when we started the company, the idea was we will capture an ungodly amount of 3D data, build a flywheel that allows people to capture that, and for us to be able to use it, and then build world simulation systems with it. So we released an app which is called Luma 3D Capture. It actually was very, very popular because one, the results were really, really great. It was for the first time that NeRF and Gaussian splats were productionized, and Matthew, he joined our team actually to really push forward the frontier of that sort of the world. But very soon we realized that doesn't matter how many people use the app, it will never reach the scale that was necessary to learn enough about the universe.
Why is that?
Because think about it, right? The number of people that are writing on the internet, that are taking photos on the internet, that are capturing videos on the internet, substantially outpaces anything one company can actually distribute. Also, there's decades and decades and decades of that information that is already available. So it's all about data. It actually, you can make the case that this particular modality of data is better for learning versus this or versus that. It really doesn't matter. That's a moot point because you're running against the physics of scale. So wherever there is scale in data, that's the only thing that's going to work. And you have to design the algorithms around where the data is, not the other way around, right? You come up with some pristine algorithm, but you don't have any data, then what's the point? Robotics is coming up against this problem right now. We're all right, we're going to build these action systems, but well, where is the action data? There's no internet of action data. You can have huge labs in China and India and Vietnam and everywhere gathering this data, but the scale is really not comparable. So you have to just design the systems around data. So that's what we learned. So in 2023, after that realization and after NVIDIA Hopper architecture was announced, we started to build the foundations of generative video. Because video is three-dimensional. It has 2 dimensions of space and 1 dimension of time. And human brain actually learns about 3D representation through that time proxy. So when Hopper architecture came about, we started to think all right, it might be possible actually to learn video and to learn the world representation through video. So in 2023, Jiaming joined us. Jiaming was at NVIDIA at that point. He's a Stanford grad. And a few other people from Stanford and Berkeley started to join the company with this idea of all right, let's learn from video. And we started to build that infrastructure. And in March 2024, we released the first video model that was called Dream Machine. And in the first 4 weeks, actually, we got up to 6 million users from that because people had never seen generative video. Sora was announced but never released, so people had never experienced it. So people really wanted to actually try that out. So we started with video at that point. And then we have had the similar realization again in 2025, early 2025, it's just annual cycles now, that just video is not enough because video is good, but it doesn't pair human logic. It doesn't pair why an event is important, what is the sequence of events, and what does that actually lead to. Just having language models in the middle that are being used for embedding is not sufficient. You need unified intelligence, so that's kind of where we are now.
Yep.
So these are the dots.
Well, so this is not the first time the class has heard that when you close the loop, you have to sort of evolve the mid-training, the post-training pipeline, the interface. And so can we spend a little bit of time? So I don't think it's a surprise for people to hear that there was sort of an iterative loop every year as you got more and more data from customers.
Yeah.
But can we talk a little bit about that first, the final projects for the class this time are the one-person frontier lab where they're going to be bootstrapping their own flywheels.
That's pretty cool.
And the first, before, I remember, how nerve-wracking it was for you and for the team when you had the realization that video was going to be the future, but you didn't have a video model out in the world yet.
Yeah.
And you didn't have a state-of-the-art system to start collecting that that context feedback loop.
Yeah.
So let's take a bit of a journey back in time travel to the launch of Dream Machine 1.
Yeah.
Can you just tell folks how you went about kickstarting or bootstrapping the video flywheel at Luma?
So I think the core problem that you want to think about, whenever you're building these really, really large systems, they have a wild distribution, right? Like, even if you're talking about language models, well, they have all of language model data, and what is good, what is bad, right? So you want to think about, okay, from this really raw distribution I get from pre-training, how do I get to a model that humans can use? And what humans find useful is a very narrow band within that distribution. And that narrow band is not like, a predictable linear band. It's just like, pockets of greatness that humans think are great. Some other species might find it very different, right? But we have our own aesthetics, we have our own use cases, we have our own value systems, so we find those distributions valuable. So now the question becomes, how do you find, or how do you basically get that distribution out of the model? So we started to think about that problem, and with Dream Machine, because there were so many users that were using the model, the question became, all right, can we learn something about that? And preference, preference feedback, at that time, by the way, SFT, right, was just started to being thought about. RLHF was a hard thing, where people were thinking about, all right, human feedback loops. So we built a system where videos that people were liking and people were downloading, we considered that to be a signal of all right, this is something that people prefer. It was not 100% accurate because some people were downloading really bad videos as a showcase of how bad AI is at video, right? So our model also learned a lot of that. So we had to then build systems for humans to be able to go and filter out, people we pay. So then it started to emerge what a frontier lab actually looks like. A frontier lab has these components of data, these components of compute and algorithm, but it also has huge parts of what we call skills and trainers and tutors and people who are doing the labeling of data and all of these systems. If you don't have that, that is actually not complete. And a part of that is also the product you built. Can the product actually give you enough information to make sure that the next model is better than the previous one? And hence the experience is better, and hence more people will use it, and hence you'll get more data from it about this preference of human distribution, and can you make the next model actually better? So, it took us a long time to learn actually how to gather that feedback, how to, and then now the system we have in the latest Luma agent system, ungodly amount of feedback actually we get from what people are doing. Every interaction that is there, we learn from whether they like it, dislike it, in what way they like it, what way they dislike it, whether the full chain of thought that the model produced and the full chain of work that the model produced is any good, which elements of that is not good, and then that's how you actually start to get good at it. Yeah.
Well, let's, why don't we do a double click on how that actually works? So to remind everybody about the field trip we're about to take, right? This is the very basic standard AI factory we've talked about, right? Frontier AI sort of pipeline. We got pre-training, mid-training, and then we have post-training and deployment. And so today we're going to hear a little bit from Amit on how the Luma version of this works. So why don't you go ahead and just kind of talk us through what's actually going on under the hood at Luma?
Absolutely. So let me talk about what is informing the design decisions for our architecture and for our models. Currently, we're seeing huge amount of alpha coming from language models being used for adjacent tasks like coding, for adjacent tasks like system design and those kind of processes. But when we start to think about tasks that require more context than what is available in text, so creative work, right? Huge amount of things, a huge amount of information that is in visual domain, huge amount of information in auditory domain, actually huge amount of information in the trace of how you arrived at the final output, right? That. When we think about robotics, you can definitely start to build a robotic system just based on text models or VLMs or VLAs that people are starting to do now, but they will not generalize. Just the same way that autonomous driving didn't generalize until people started to build full end-to-end systems that had language, that had video, that had all of control signals, all of these things in there. So that's the problem we are coming up with, that the real world is way more complicated than coding. right? I mean, coding is a really valuable task, but not everything can be done in coding, right? Like otherwise programmers would be the only profession that would be left. And now they're also, endangered species, actually. But
I'm not sure that's true, but I understand your point. Yeah.
As a programmer, it's really fun.
Well, the
actually.
job has evolved for
That's
sure
right.
to become a trainer and a tutor. Yeah.
It's a really fun time to be that way. I started coding when I was 13 years old, in order to build simulation systems, in order to do so my background is in physics, and in order to actually build simulation systems for electromagnetism and those kind of things, to see how these systems behave. That's why when I learned to start coding. And even at that point, it was really obvious that I cannot teach those systems from any observations, right? We can write the code, but that is like approximations that we have in our models or in our equations, but we can't actually teach those models from any data. So all of this is informing how we build our systems. So even early on, we started to think about, okay, in our pre-training, how can we learn from all of video, all of images, and all of text, right? It's a really hard problem because they're really different modalities and they're expressed very differently. If you think about the encoding of these modalities, text is discrete. And text performs the best when you encode it in a discrete manner. At least that is understanding today. Video is kind of somewhere in between. And audio and images are best performed in a continuous space. So our factory, as you call it, is built around this idea of how do we learn jointly from all of these systems. In 2025, these were disparate towers that we built. Language tower, image tower, video tower, audio tower. And then we would unify them together using just some fusion techniques so that they will do better. If you look at the work from Andy's lab, right, stable diffusion, those kind of things, that's what it does as well, where you have a tiny little language component, right. And you learn embeddings from that to be able to understand the human instructions. It was just not sufficient. So when we talk to our customers, when they try to use our system, so where are systems being used, right? For instance, currently, large studios. So actually, I'm very, very, very excited about a new show that is coming out on Prime Video. The trailer's out. It's called Old Stories. It's about Moses, right? So it has Sir Ben Kingsley is the star of it. It's a proper production. It's not an AI video. It's a $4.5 million per episode production, basically. And it's pretty much all produced using Luma agents. So they're using it in these really high intense situations where they want to be able to model the whole world and the physics of the world and light and fluid and interactions and all of these kind of things. Now, when you do that, it's just not sufficient to build an image model or a video model. You need a model that understands time and causality and language, right? And it understands proper instructions. Okay, well, this looks good, but what if the shirt sleeves had this particular thing right here? How do you express that instruction? Okay, in time, when this person actually walks through the door, the whole scene explodes. All right, what does walking through the door actually means? When the person walks through the door, what does this explosion of the scene mean? Give me more instructions, right? The deeper you go into these kind of problems, and this is a very, very, very big market, right? It's about 120 million creatives in the world. This is their job, right? These are not people who paint for a hobby or all these kind of things. These are people who actually are employed in this industry. So about 2 times, 3 times by estimation of coders. Their work every day goes into replicating the physics of the real world into computers. So we want to build systems for them. And if you want to do that, you want to build what we are now calling unified models that have the same understanding and intelligence of a language model, that can follow context, that can remember, and the physical understanding and the world model understanding of video models and image models. So that is what the output, that is what the things we want to produce. This was 2025. And now in 2026, when the models got really good, what people want to do is they want to do the full work, end to end. It's all right, why is it only producing 5-second video for me, right? Why can't it make the whole shot? If we go to people in advertising world, why can't it make the whole campaign? If you talk to robotics companies, why can't it actually produce the whole action and then judge its own outputs and then tell me when this is the right action and incorrect action? Why can't I get the right force and all of these kind of problems? So people want end-to-end results. So now the Luma factory is about building systems that can do end-to-end work in multimodal domains, So that's kind of what we do. We have massive reserves of multimodal data. In about the final trainable outputs are in about 30 petabytes of scale. We train them on currently H100s and very soon GB300 GPUs in the 010K scale, basically. So pretty much the same as a second-tier language model training. So we're not at 1 trillion parameter yet because that scaling hasn't been figured out, but we're going to get there. And then we do post-training on this stuff using huge amount of customer data and huge amount of user preference data, as well as data that comes from our own human annotations. And finally, we put them in production and we do reinforcement learning and continual learning on those systems. So that's the shape of the factory currently at Luma.
And could you talk a little bit about, when you started deploying these systems in the first lecture, we talked about mission critical contexts, right? And one type of mission critical context is a large studio for whom their data is super sensitive. They don't want, they're happy to have you train their data, but with their data for them, but they don't. If I'm running a studio, I don't want my data being used by another studio. So how did you navigate the deployment sort of restrictions of these professionals? So
we work with two arch nemesis at the same time: Netflix and Amazon Prime Studio, right? Which are the two giants of streaming war at the moment. So basically, then you have to build systems that are guaranteeing that there is no way that there's any data overlap. We have internal controls and systems that are some of the standard ones like SOC 2 and those kind of things, and then specific ones that are for AI labs on how do you not train on this, on this data. So for instance, if you're producing the next blockbuster, you don't want the next Iron Man, for instance, right, to show up into the training data. So we have guarantees around that, all right, whenever certain stuff is marked or projects are marked, they will never show up in training data. They will never show up in any of these loops, basically. But we still learn from what users are doing in the product, which is different from the visual artifacts that they're producing, but rather the traces they're producing. We were still able to use them and learn from them, actually.
This is the interaction data.
That's right.
When people are working with the interface of the agents.
That's right.
Okay.
So there's some limitations on these kind of higher sensitivity projects.
I think you have could you talk a little bit how you created these slides? Because these I believe were created with Uni 1.
That's right.
Is that right?
So these are, I basically gave it, actually, let me start from that first. And then I will actually talk about unified models as well. So here, I created this, on the top, what you see, I created that mind map, whatever you want to call it, in our product. And then I basically asked, if you see on the right, I asked it, and I also gave it Ant's slide, that the one right here, sorry, not this one, but, okay, I don't know. The first one you saw of the factory
slide.
That's right. Yeah. I gave it that and asked it hey, in this style, actually produce the outputs. Now, this is actually a very, very good example of what unified intelligence that I'm going to talk about means. People, when they think about image models, video models, or any models, not text, they think they produce beautiful images, right? But that is a really big mental gap that the world has in this area. Just like language models produce words, right? The words can be beautiful. You can just say hey, it's a poem, and it could mean nothing, right? And simultaneously, you can have a mathematical proof of Erdo's problem number, take your pick, right? 1152. They all are words at the end of the day. But how you string them together determines the information content and determines the intelligence of those. Just like that, how you arrange the pixels determines what they're conveying and how intelligent they are. So unified models that we are producing now, and I'm going to talk about that in a second, are about how you express intelligence in whatever medium is convenient for the person that they are actually, who's using it. So if a language output is convenient, fantastic. If it is slides and images, fantastic. If it's a video explainer, great. But they're all basically outputs that are intelligence. So that's what we call unified models. So yeah, basically, it was one shot. It produced those slides. It produced one that I didn't like and I deleted, but before you asked me to take a screenshot of that. But that was pretty much about it. If I would have asked it to do a very detailed overview of that, then that's what it would have done. So end-to-end work. This is what we call end-to-end work, right?
So just to break down what happened, you gave it my original slide as a prompt, a screenshot of that prompt.
Yeah.
You then gave it instructions on the right in the chat. and then you gave it a little bit like guidance. Is it that
Yeah, just
scaffolding?
my thoughts up there.
Right.
The top half of the screen is like, my thinking.
Right. And then the
And-
output below was
Yeah.
essentially the slides one-shotted from that.
Correct.
Okay. And why was that not just possible trivially? Why can't an LLM do that? And why did it take so long to get here? What's the hard part about this?
Right. So, I mean, that's a good segue into unified models, basically. So, well, LLM, first of all, doesn't generate images, right? I mean, it's a language model. You can ask an LLM to use a computer and try to generate images, but again, it really falls apart because it doesn't see anything. So when it tries to reason spatially, when it tries to produce, like, any visual outputs, they're blind models. They see everything as a full sequence, right? Like, even the grid nature of images and visual information is not apparent to LLMs. So when you start to do VLMs, which are vision language models, right? Like, you start to teach them a little bit about image part of it. VLMs are still not generative. VLMs understand images, but VLMs can't generate images. So we have on this world where, like, you have understanding in language and generation of text, and then you have models like Flux, which are good at generating images, right? Which are great models, by the way, right? But then they don't have any of this understanding. Right, and I think Andy talked about that last time as well, that, like, there's this big chasm in between these two things. Understanding is separate and language is separate. Oh, sorry, and generation is separate. But in language, that's not true. An LLM is good because it understands text and generates text all in one go. Right? There's no delta in between. There's no two models that are actually doing it. If we want to solve world understanding and quote unquote world models that people are calling it, that's what we need to do.
But for at least about a year, I guess, we've had models that can generate language tokens and image tokens, right? Like with Nano Banana.
Right.
But they was like Nano Banana was still not able to generate. I remember trying to generate schematics like this. I tried to generate the factory slide with Nano Banana. I couldn't.
Okay.
Why were the capabilities still not there with basic sort of like these jointly trained models?
So from what we know of Google's architecture, Nano Banana is still a fused architecture, where, like, there's a large diffusion tower that is generating images, and there's a large language tower that is generating text, and there's like a thin bridge in between them. So, like, you generate huge amount of text. It's called EP, enhanced prompt, and that text you take and give it to the image model. And that image model's job is now interpreting that text using a very thin, narrow VAE, right? Like, and some encoder. I don't know what Google uses for their internal encoders, but these encoders are like 700 million parameter, 800 million parameters. That's the best you're able to actually get out of it. What we're building in unified architecture is different. So our approach is, well, transformers are probably the single thing, like, if I was coming back in time, this is what I would bring with me, the transformer architecture. And I will give it to people that, like, all right, go play with this. Transformers are very good at, they don't care actually what kind of information you're passing through them, right? Continuous, discrete, actually it's all okay. It's the pre and the post of it that, like, the encoders and decoders, when actually things start to fall apart. So in unified architectures, what we are building are these, actually, I didn't order it correctly, but anyway, this is a pretty bad diagram of that because, again, I didn't try to go with the architecture diagram, but that's kind of the idea. One single transformer, or maybe one single backbone, you encode this information in the same space, whether that is audio, image, text, code, doesn't matter really, and then you reason about them all in the same backbone, just like the human brain, right? So human brain, while it has different areas for processing image information and or visual information and auditory information, those kind of things, but those are just encoders. All of that information then goes into the neocortex, or maybe a little stages before that, but anyway, it ends up in neocortex, and reasoning and thinking and all the judgment happens in one single place. This is how we build the next generation of great models, right? Like, that are able to do more tasks than what LLMs are able to do. It took us about a year to come up with this architecture. A huge number of failed attempts. You probably know, right? I don't know how long I have been talking about this. Huge number of attempts at trying to scale them, all of that things. But now we are at a place where we are pretty comfortable and confident at building, hundreds of billions of parameter models out of this architecture, and we know that it is going to scale. So now there's efforts within the company at all of these modalities, but one single model, one single architecture, including language.
Right.
So yeah, that's unified architecture for it, Luma.
Makes sense?
Yeah.
Did you have any more before we switch to Q&A?
Yeah, so actually, let me talk about how we deploy these architectures, first of all. So this is what we are trying to build. If we wanted to do end-to-end work, this should be very familiar. Like, if you've taken CS class, it's the REPL loop, read, eval, print loop. This is how computers work, have worked for a very, very long time. If you think about the von Neumann architecture, it is built around, the REPL loop generally. It was not thought about at the time this way, but now we think about it this way. If you want to deploy models to not just produce text tokens or image tokens, but actually to do work, end-to-end work, how do you build these systems? So how do you do that REPL loop? One way is doing the left one, where you have different models for each kind of things, and there's two schools of thought. You produce federated models, or you have this kind of tiny models that are each doing specialized work. And then you make them combine, or you just pass outputs from each other, and you probably have a judge model on top that judges and orchestrates all of that work. That's approach one. And approach two is that you have these mega models in the middle, and where they share this deep connective tissue, and they can reason in one single space, and you give them inputs, and you expect outputs of them. They're iterative models, so it's not one shot, all the outputs that are going to come out. But we are betting on this second approach. And the reason is very simple, because we think intelligence is not this pipeline architecture problem. If you think about the systems of intelligence, the systems of intelligence don't look like this kind of big database problem. The systems of intelligence look more like the human brain, where you let information itself design the architectures and circuits inside it, like what we do during training. And hopefully very soon in continual learning, these circuits will change as we are actually using these models. And then you sort of step away from that. You manage context outside. You manage memory, sometimes outside, sometimes inside, like how you do with caches in CPUs today. But the actual processing unit are these unified models. So that is sort of our approach of how we think about building them. And how we think of improving them is a little bit like this. So if you want to think about what is a computer of the future looks like, actually what is every agent product today, it's some version of this, basically. This is not a big revelation. This is how things are being built. So you have a tool harness in the middle. I'm going to go from the middle up. This tool harness means systems that can use Linux, systems that can use call APIs, all of these kind of things. But then how does it all work? How does it actually, full work gets done? So you have this fat stack of skills on the top. These are domain-specific understanding, right? So you want to teach a robot how to assemble something, right? That's not a normal thing, right? If you want to think about how is an iPhone assembled, this is a very domain-specific thing. You can give it all that information. It doesn't need to be in the model. It doesn't even need to be in the tools. You give this information as context. And you can do this across huge amount of verticals, huge amount of different tasks in those verticals. Then you have tool harnesses where you give it as general ability to call tools and things like that. And finally, orchestrating all of that and thinking through all of that is this unified model at the bottom. That is interpreting all of this multimodal information, generating tool calls, understanding which skills to use, and producing the outputs. So this is how we think the architecture of the future of computers will look like, and this is what we have built the current product basically on. This is basically built on this kind of architecture. So, yeah.
So actually, could you just do a one-to-one mapping? So here, where was the harness? Where was the skills? Yeah. Where was the model?
So actually, when it generated these slides, right, someone on our team who's really, really good at producing greatly designed slides wrote a 50-page document on what it means to design good slides, right? And if you see, actually, I don't know if the prompt is there. I've got a clear picture, now kick off planning and generation. Okay, so after this, it would have said let me look up the skills I have access to.
So that was the skill. That's a general purpose
slide skill.
Best in class slide creation skill.
Correct.
That was created internally by a human and then uploaded for anybody else to use.
Exactly.
Automatically.
Exactly. So that's the skill layer. Then the model layer is obviously the one that is generating and generating the tool calls and all of these kind of things. And the tool layer here, so not many tools were necessary, but I think your image that you gave, that was also passed as context.
Right.
And we probably ran OCR on it, just to see what kind of things it is. So this was not a very tool call heavy thing. But had you asked it to make an interactive web page
right.
that animates all of this stuff, then it will go on and call coding
skill.
tools,
Right.
tools to run that code, deploy that code, all of these kind of things. So it will have done all of these things, but it's the underlying model that is orchestrating all of that.
Okay, I'm going to ask you one last question before we switch, which is, okay, so it took a couple of years to put the whole system together, which is a fairly high-scale system. Can you talk about the business for a sec? You announced earlier this year, I think you raised about $1 billion.
1.5.
1.5 billion.
Yeah, total.
Yeah, over the lifetime, Luma's raised about 1.5 billion. Of that, I think $1 billion was raised these last 12 months. Why is this such a capital-intensive effort if it's not as high scale as language?
If you really want to do it correctly, it is larger scale than language, because it is strictly a superset of the work that is going on in language. But currently, we don't care as much about coding, for instance. So we don't have to spend that much effort towards it. We can go towards all the areas that language models are not good at. And that means we can actually have a subscale compute infrastructure, subscale data infrastructure, things like that. So it doesn't require 100 billion yet. We can do with 1 billion what generally takes 5-10 billion annual run rate to be able to produce. But if you think about it, where things are going, in 1 year, 2 year, 3 years time, we believe that these systems will far surpass language systems just because of the access to more data. More data is better, right? Just because of their understanding of more domains. So I'll give you an example. One of our customers who's using these systems, they work in energy industry. You can guess who that is.
Right.
And now suddenly, our systems have no idea about, grid systems. How the energy grid actually works and how they want to be able to do that. So what we did is we started to ingest their energy grid diagrams and energy grid code and all of these kind of things. And suddenly our systems are better at producing schematics and planning than Anthropic's coding models are, because they can't actually read all that information. They can't actually see how the things are laid out, that sort of problems. It's a very small example. Studios have another big example where yes, LLMs they have had forever, but a story is not just text. A story is all of the physical stuff that is happening. If it has visual understanding, it can do much better. So we believe especially as the age of robotics comes about, you will need these systems to be general, and these systems to be able to do everything, including writing code. And that's kind of where we're going to go. But today, this gives us a very great business where language models are not really playing. Currently, we are, when we started the company, we were very small. Today, we work with some of the largest studios in the world. Now we work with the largest advertising agency in the world, Publicis. They're just deployment channels for us. We work with the second largest brand in the world, Coke, who is moving $3 billion of annual production of content to Luma, basically. And in addition to that, in some of the areas how do you do work just in a company? How do you communicate information visually? There's starting to be these new areas in which previously only designers and artists could work. Now everyone is starting to do that work.
Yeah, so this was, you had an event earlier this year. I think it was 3 weeks ago in SF, and I came by. And the thing that shocked me was that it was all artists and creatives. And you spoke for a little bit off the stage, but then they got you off the stage. Yeah. And then a bunch of folks from Hollywood came by, a bunch of designers. And it was the first time I'd seen so many artists and creators, not like machine learning people, but creatives excited about using tools. Why has that's very new. But, there was a lot of
negative
fear, uncertainty, doubt a couple of years ago that this was going to actually take away jobs in the creative industry.
Yeah.
But for whatever reason, these folks, these are some of the biggest names in the creative world.
Right.
Some of whom were actually opponents of the technology a couple of years ago. What changed?
I think the technology at that time was not good enough. And they were just looking at it from the angle of first of all, it's using all our data and it's not good enough. So what is the point of all of that? But through all of this work that we have been doing, now the value is starting to become it's in their face, right? So when we go and talk to companies about our work and what the products are doing, what we do is very simple. We actually sit right there, and someone will open a board and start to produce their stuff. So actually, this happened recently at a gaming company, Savvy Games, and they produce Monopoly Go and some of the most played games in the world. And we were talking about it, and everything was hypothetical. It's it will scale up production, it will reduce cost, all of these kind of things. And then I was just I took a couple of their assets and we produced about a 500 scale campaign while we were sitting and talking about it, right? It's like you can do it for all of these different things, and we showed right there. When you see that, it's the same thing that coders are having that moment today. It was all slop before, right? Slop just means when someone says slop, it means they have never seen or used a good AI system before, right? When you see the results and you're like, this is as good or better than what I can produce, or at in the similar ballpark at least, their minds change. Hollywood studios were, and still are, very apprehensive. But now when they start to see, the production that we have coming out, we actually show them, and they're like, there's no way this is AI generated. And then we show them the backstage production of it, right? And then that changes my hearts and minds. So the best way to change hearts and minds is to just do good work and actually show them.
But why does that mean the existing folks in those jobs have more productivity, or they're getting stuff done faster? Like what is the benefit to the creative? Let's put the business people aside for a sec. The creatives who are using these tools, what's the benefit to them?
Yeah, I think it really changes the game of what they're able to do. So in a couple of ways. First of all, right now, execution is at a premium. So you do so much work to validate the idea ahead of time. And this is all across AI, by the way, not just for Luma. You do so much work oh, is this the right idea once we put the execution resources on it, right? But think about it. It just changes the equation completely. It's all right, let's execute on all of them and produce the thing, and we'll see which one is great one. When you think about some of the best creatives in the world, and I don't mean creatives like just visual creators, right? People who made anything, they end up being prolific. If you look at their life afterwards, right? If you look at Einstein's work, right? Yes, relativity is huge, but there's also huge amount of work that went into Brownian motion, huge amount of work that went into light, and lasers and photoelectric effect, right? If you look at Archimedes, incredible amount of work. If you look at Mozart, just ungodly amount of work. Some of them was good, some of them was not so good, right? People who are great at what they do are not just one-shotters. They actually produce a huge amount of stuff. Currently, if you look at just our industry, artists and creatives are stuck in this industrial system that measures every action they do by the output that they're producing. This is no way to do great things. If you want to do great things, you should have the liberty to just explore basically, unconstrained. When they start to use our stuff, they feel unconstrained. And I think that is what is bringing a lot of creatives on board.
Because you can paralyze
exploration.
Exploration, I see.
Right? And then you get to produce better things than you could ever do. It's more enjoyable because you're not in the slog of every single pixel and all these kind of things. You come at a higher level.
Right.
This is what the moment coders are having too. It's all these ideas I had, they're not just stuck anymore. I can just try them out.
Right.
Yeah.
Okay, I think we should switch to Q&A. I'm sure there's lots and lots of questions.
So the question is, what is my hypothesis why Sora shut down? Whether it's a business reason, it's an architecture reason. And two, what impact does it have on us in the industry, but also on creatives? So, I can only give you hypothesis. I don't know really what is happening inside OpenAI. But the one word here is really focus. OpenAI, at the core of it, is a large language model lab. What they do really, really well is produce models that are very good for chat, particularly, right? Chat is a vertical that has about 8 billion customers, right? Maybe not little kids, but maybe they too, right? Because they want to talk to computers. So pretty much all of humanity is a good customer of chat. Executing on that is a really hard problem. Executing on anything at that scale, you need to go into the depths of hell to be get everything working really, really well. When you do everything, that's really hard to do. Luma also had that problem actually, right? In early days when we were not really clear about how do we execute on this. So we tried a lot of parallel paths. But doesn't matter how much money you have, doesn't matter how many people you have. This was also a lesson from Apple. There's way more things at Apple that they choose not to do than they choose to do, right? That is because it doesn't matter the money, doesn't matter the people, the organizational physics still come into play.
Less is more.
Exactly. There's only so much attention you have as a company, not as a person, but as a company that you can actually devote to making something. So OpenAI doing literally everything is not good for their business. And I think that is a realization that is setting in. And I think this will not be the last thing that they have actually canceled, right? There might be actually even more. One thing I will challenge is OpenAI was not the largest player in the market. It is actually Google that is doubling down on video, on images, on visual generation, right? Gemini has great models that do pretty much all of these things actually. It doesn't indicate actually anything on the size of the market. It just indicates that they are getting their kicked because of lack of focus by Google, by Anthropic, and those kind of things, and they have to focus if they want to go IPO, right? And that's the market that we are actually entering at this point. For Luma, what does this mean? I mean, this is great news. This validates, like, our thesis that, like, you can only do so many things at a time, and this is the area that we have chosen to go in because this is a very, very big market with huge number of people that call it their profession. So it actually gives us a very good footing in the same market. So that's what I would say. So the question is, given that anyone can make a video about anything and content about anything, what happens to copyright, right? So I think copyright and the ability to produce something are orthogonal problems, right? If you're talented enough, you can make Mickey Mouse in Photoshop, really, and you can actually produce great stuff about Mickey Mouse. Like, let's say you're DreamWorks. You don't have rights to Mickey Mouse, but you have all the people who can actually produce anything related to Mickey Mouse, but you don't. Why? Because the law exists that, like, prevents you from doing that. So I think none of that has changed. Has it become easier to violate other people's copyright? Yes, I think so, right? You didn't ask me, like, what the responsibility of platforms is. Again, the responsibility of the platforms is the same as it was for Photoshop, right? Like, it's not Photoshop's responsibility to prevent you from producing Mickey Mouse. It's your responsibility as a law-abiding citizen to not violate the law of the land. So I think it is pretty much orthogonal, basically. Like, generative AI doesn't change copyright in any way, shape, or form, at least on the output side of it.
But specific, if there's a law that says you can't do X, Y, Z, you will adhere to it.
Absolutely.
Yeah.
If we get a DMCA notice, we'll take it down, right? Like, if you're hosting it.
Right.
If that person used to create it and we get a call of, like, all right, like, this person made something, it is not our responsibility to point law enforcement to them, right? Like, because that's not the law of the land.
Ah, right, I see. You protect the users in that case.
That's right.
Right.
So the question is, GANs were very popular 2017, 2018, and now, the world has shifted pretty much entirely towards diffusion models. What is the space of GANs in today's models, or today's architectures, basically? That's a great question, actually. We still use GANs quite a lot. We use techniques from GANs quite a lot. But GANs are one of the most finicky architectures to ever work with. So GANs, if you don't know, are generative, adversarial networks. And as the name says, they're adversarial networks. So, like, you design the objective in a very different way to diffusion models, right? Like, where you have a very predictable gradient descent. I mean, they still explode sometimes, but it's a very predictable system. GANs are still actually used quite heavily in distillation networks. Like, if you want to do distillation, like, GANs are actually pretty useful. If you wanted to do a real-time system, you would still go to GANs quite a lot. But because GANs are just not very predictable, researchers don't want to work on them. And that is the laws of, like, physics in AI. What researchers want to work on is generally what will get worked on, right? Like, so I could make the case that, hey, Rust is more efficient. Doesn't matter. Everybody wants to code in Python. So that's what will be done. But also, GANs have not shown the kind of scaling that we are seeing with transformers, right? GANs are primarily, unit-based and convolution-based models. And they just don't really show the kind of learning that you can get from transformers. Can GANs be implemented using transformers? Yes, there are some papers about it. But at that point, you're really, really trying very hard to, like, just do GANs. And that's okay. But diffusion models also now are on the way out. So I know this will be a little bit controversial if people are thinking about it. But diffusion models have physics that is not actually bearing out on scaling side of it. So Luma and some of the companies are actually moving away to hybrid autoregressive and diffusion regimes. That's what our unified models actually are, because diffusion models actually have some really, really bad habits that are hard to unlearn and hard to, like, get out of the system. So they're also on the way out, actually. So, yeah.
It's a very, if you realize, basically, when we first started teaching the class, Mike, there were debates about what the right programming language was for security, and it feels like architectures have come full circle, basically. Good note for office hours this week.
The question was, as models get more and more powerful, what is the space of human creativity, especially in these unified models that can do pretty much all tasks, visual tasks, language tasks, all these kind of things. My stance on this has been actually very, very sterile from day one. I don't think anything the model is doing is creative or not creative. Whether it's creative or not creative is for humans to judge. That judgment alone is the act of creation, right? What you choose to do is an act of creation. How I tend to spend my time is actually a very creative endeavor, right? Because it will produce outputs that people will consider creative or not creative. But more importantly, in a practical, physical system that is an AI system, where's the role of human? It's in that fat skills area. This is why our slides look good, because someone who knows this really, really well went in and taught the model 1,000,000 times over that, this is what good looks like to humans and this is what bad looks like to humans. This is just like programmers, right? Before, artists never had this kind of huge leverage. They did something once and it will run 1,000,000,000 times, right? Programmers have always had this leverage. You write the program once and it will run again and again and again and again on everyone's computers, on everyone's phones, many, many times over and produce value. Artists produce one thing and then that's one thing. That's it, right? Now, other creatives in the world, not just programmers, have this leverage because of this architecture. You teach the model once, and they're able to produce huge amount of really, really great things in different contexts. This is actually an explosion of creative potential that this never has been, right? So the skills and human creativity are much more important. Actually, it will weed out people who were mediocre, and it will elevate people who are really great to even greater heights, because now their work will be rerun 1,000,000,000,000 times over. Okay, so Hollywood is default dead right now, right? And that has nothing to do with AI. That has really nothing to do with any of the technological changes recently. Hollywood's business model has been deteriorating for the past 30 years, and COVID really accelerated it, and then the writer's strike just was the nail in the coffin. At this point, we are at a place where, this production that I'm talking about is the first production in LA, proper, in the last 5 years. First production. Because all production has moved out of Los Angeles. Think about it. Hollywood doesn't make movies anymore. Hollywood finances them, but doesn't make them.
Where are they being made?
In Greece, in Canada, in Ireland. Wherever you get tax incentives, you're going to make it there. So what does solving this problem actually mean, right? First of all, Hollywood has to stop thinking like PE. Currently, Hollywood's business model is like a private equity. Oh, Guardians of the Galaxy was a great hit. Let's make number 2, number 3, number 4, number 5, number 7, number 10, number 20, right? How many Avengers are there now? I don't even know, right? And how many crossovers of Avengers in Spider-Man? And I won't be surprised if, Tintin is in there one day, right? Some multiverse thing. As a physicist, that's a really troubling thing for me, the multiverse universe, right? That's not how it works at all. But it is emblematic of a PE mindset where all right, we created a franchise, we created an asset. How do we seek that asset the most we possibly can? But audience don't think like that. More and more people want to watch great things, want to go to theaters, want to actually watch things on their phone. That is emblematic in Netflix's growth. I mean, on Thursday, you're going to see this quarter results. I'm not saying buy or sell anything, but you're seeing the growth of Netflix, and they produce 800 productions a year, compared to the 5, 10, 20 that large studios are producing right now. That is the PE mindset. So those 800 productions don't have $500 million budget, right? They have they're like 10 million, 20 million, 30 million, $50 million budgets. And this is how they're scaled. What does this allow? This allows different kinds of and more kinds of stories to be told, and that means it appeals to a wider audience. So your platform then becomes more appealing to more people. Are they making, again, a Harry Potter? Yes, I'm very happy about it, by the way, right? But this is also PE mindset, that why are we making Harry Potter when we have so many other great books that should be made again and again and again and again, right? Shouldn't be made again and again. So Hollywood has been default dead for a long time. If nothing changes, this is not about AI again, if nothing changes, all those jobs are actually already gone, right? The people in those industries know that. AI is a chance to actually change the business model once and for all. Because you can move away from these massively expensive production methods. You can move away from these huge time and capital sinks and go back to an era where many ideas can be tried, and one has a shot of building people into into theaters. Ryan Gosling from Hail Mary, if you have not seen it, great movie, makes a great point. It's not the audience's job to come to the theaters to keep Hollywood alive. It's Hollywood's job to make great things so the audiences want to watch it. You can't blame your customer.
What I'm going to do is, that was well said, and I think the P mindset is going to come up over and over again, where capital markets, wherever they look for predictability, we tend to find stagnation of innovation, and I think that's hurting a lot of people.
That's a great question, and that's the one that the whole company spends all their time thinking about, honestly. So the question is, what is the delta between where we are to getting to a place where world models, video models, whatever have you, are as generally used and useful as language models are today? Fair? Right. So there's only one word, basically, intelligence. That's the delta. So currently, image models and video models that are not unified models are really, really stupid. And I mean that in a non-derogatory way of that, right? When I say stupid, I mean in this way. Like, when you work with a person who you don't consider to be intelligent, what are the signs? They forget what you said. You have to tell them the same thing again and again. They don't actually understand what you said. They kind of are a facsimile of understanding, right? It's like, you said something, but they're like, but that's not what I said. Like, yes, you kind of interpreted my words literally, but that's not what I'm saying. You have no context of what I'm saying. They are able to do small things, but when you ask of more of them, then they can actually do that. This is what today's video models and image models are. All of them, basically, right? That's what we try to solve with Uni 1. They need to be as intelligent as language models are. They need to have multi-turn, right? So when you ask it something, afterwards, it needs to be able to go back. It's like, all right, this is what I generated. This is what you had asked. I have memory. Let me iterate on it and let me fix it. How annoying would ChatGPT be if you only had one turn on it, right? And then you have to repeat the thing and then another turn, and repeat the thing and then another turn. That's ridiculous, right? Nobody uses that. See, that was the difference between LLMs being a research project and them becoming generally useful. That was RLHF, right? That enabled chat, multi-turn. So that was number one. Number two is how much intelligence did they actually have? So current image models and video models are beautiful pixel generators. They have really no understanding of what the hell they're generating, the physics of it, any introspection on it, all of these kind of things. Unified models are designed to solve this kind of problem. So when you use them in things like education, for instance, right? These slides could, sorry, not this one, but the ones I had, could easily be used by teachers, right? With probably a lot more density, and I can show you really good examples of it producing really high density things. Videos are some of the best explainers in the world, right? Imagine a history class that is not taught as drab text, but you can actually see. And most importantly, you can do alternatives. What if the Rubicon was not crossed, right? What if Caesar was not murdered? What if, these things didn't happen? What if Archduke Franz Ferdinand was not shot in 1914, right? Would there still be a World War I? I posit yes. And, we can go into that. But what if you see that flow out? You had this level of, temporal understanding and coherency and these kind of things. Language models are getting there. Image and video models don't have that. That's what we need to solve. So that is the distance between them being just tools that can produce almost stock footage to things that can do end-to-end work.
Awesome. Thank you, Amit, for being here.
Thanks for having me.